Okay, everyone. Let's get the show on the road. Does that work? No, I'm just gonna shout. Okay. All right. Welcome to Hacker Society, where we learn cool stuff, we do cool stuff, we eat tasty food, and we learn more cool stuff. Thanks for coming out tonight. This is one of our largest crowds ever, so round of applause for everyone who showed up. My name is Adam. I am the president of Hacker Society. You'll kind of see us around, but we like to run Hacker Society as a less transparent. We have a lot of stuff going in this. More transparent, less structured. So although we are USG, we are nothing like a USG organization. I hope you'll notice that.
And I will cover that in my talk in about like 1 minute.
2 minutes, yeah, one and a half minutes. Just to give a rundown of the people who run this show, we have Andrew Mason, who is our VP of ACM. Oh, that's a lot of chalk on my sleeve. We have Zach Hudson, who is VP of IEEE. So if you're an EE and you're here and you want to talk to cool things about that stuff, talk to him. We have Thomas, who is our secretary. We have Dina and Catherine down there, who handle all of the PR, and they do a fantastic job of it. Where's Ano? Right there. Ano is our money man. He is our treasurer. And yeah, this is Tim. He is the maintainer emeritus. And
Just maintainer.
yeah, that's it. And,
Just maintainer.
yeah. So
All right, with that started, let's talk about Hacker Society. So, what is Hacker Society? I have drawn you a diagram of Hacker Society. Here, you have the mailing list, which you should all be subscribed to. Here you have me. I am the maintainer. I organize Wednesday night talks at 7:30 in usually Lenin, but today here, because there are a lot of you, there continue to be a lot of you, I guess we'll still be here. This is you. You can also send mail to this mailing list or to any number of other mailing lists that we maintain. When you're like, hey, I want something to happen, you send an email to the mailing list announcing that you are organizing such and such a thing, and then it happens because you organized it and you sent the email. Okay, so over here, we have these people. This is ACM and IEEE. A fabulous organization that was just talking about. ACM and IEEE organize any number of events that require money and buy food for this gathering. Hacker Society is totally decentralized. We run via email. ACM requires precedence and things like that. Got it? So big difference. Okay, so we're called Hacker Society. What is a hacker? Okay, so there are a lot of people who call hackers things like criminals or entrepreneur. They talk about traction and search engine optimization and all kinds of stuff like that. I don't like any of those definitions. So here's another definition that maybe is better, maybe not. A hacker is a person driven to tinker and understand technical systems. Maybe better. It's a person never satisfied with incomplete explanations of human inventions. Maybe. A person who likes to push systems beyond their designed limitations. A person who is driven to make a new Jerusalem via technological means to create a city on the hill, a new society in there, in the computer. Those people also define themselves as hackers. So it's really two concepts. I can't write. I probably can't spell it because I can never spell it with Blackboard. There's community and aesthetic. On the community axis, you have people who are trying to build things like New Jerusalem. On the aesthetic axis, you have people who are tinkering with technology for the pure sake of tinkering with technology. And hackers represent the whole range in between. We do things because we think it's cool, and we do things to better society. The mission of our organization is to promote an open society through improving and understanding the technology that underpins it. And that's what we're trying to do here. So, as an aside, there's a lot of different things that you can talk about with the community aspect. There's ethics, there's what it means to build a better society, there's all these different things. And traditionally, I think that hackers as a whole have really had a strong orientation to that. But they've also had a strong orientation on the aesthetic side, because a lot of times people build things or do things for no real practical purpose, just because it's really neat. Okay, so I'm just going to skip that, and I'm going to talk about the ways that you can get involved. So contributing to Hacker Society is super easy. You can give a talk here. The way you do that is you submit a proposal on the website, or you email me, or you email another thing at hacksoc-officers@case.edu. You can give a talk not on a Wednesday. The way you accomplish that is you email the list announcing that you're going to do it, then you show up and you do it. We have a thing on Sundays called Open Hacks. You can go to that. You can help other people with their projects. You can do a project. You can give a tutorial on how to use something. You can help people out. Do a project and then tell us about it. You can do a lightning talk in front of any Hacker Society talk for like 10 minutes where you announce your project and plug for people to help you out. Or you can help us advertise these events and in general promote hacking. Okay, people often ask me this question after first Hacker Society, so I'm just going to cover it. How do I learn to do X, where X is anything programming, being general hackery? Here's how you do it. You find the docs for whatever X is. So let's say it's Python. You install X on your computer, and then you do a project. So it could start simple. It's like, I'm going to make a rock, paper, scissors program. It's going to play rock, paper, scissors. It's going to be awesome. Then you do another project. Then you do another project. And after, some amount of time, you'll realize that you're an expert at whatever the technology is. Apply that to any technology. That's how you learn it. Find the documentation, read it, do projects, repeat. All right. And with that, we're going to talk about Linux.
You want to bring down the screen for us, please?
Go ahead.
Yeah. All right. Kill it. All right, so our screen is now set, a little bit slower than usual. So I'm Thomas Murphy. As Adam introduced me earlier, I'm the Secretary of Hacker Society. I'm a fourth-year senior in computer engineering and electrical engineering. And then Andrew Mason will be presenting a live demonstration of using the command line for your information and for your understanding. He is a fourth-year senior in computer science.
Sounds about right.
So, what is Linux? It's an open source kernel, which is the thing that runs your computer, basically. It's this thing that schedules when your next program is allowed to use time on your CPU. It coordinates which program's using which CPU, and generally makes things work. It is the basis of many operating systems. So if you've heard of Linux distributions like Ubuntu, Arch, Debian, and Mint, those are all running off of Linux. If anyone has an Android phone or other device, that's also running off of Linux. And many, many more embedded devices use Linux in some way, shape, or form. So your refrigerator, your other appliances may be running Linux, particularly as we move further into the Internet of Things and more things are connected to the Internet or some other network. Will require an operating system to control the flow of data and its connection to the network. If you want the not so brief summary from Wikipedia, look up Linux on Wikipedia. So, why is Linux important? Many companies are at least partially a NIX organization, and what NIX refers to is it either uses some variety of Linux or Unix, so that either in the DevOps portion, in your development portion, in your deployment portion, you'll have something that needs to use the command line or these operating systems to operate at your job. Linux also has many powerful and well-documented tools that come pre-installed. So if you want to start using it, once you have access to it, you can start doing whatever you want. You can also easily install more tools to start building simple systems very, very easily. And then when you're ready, you can go find the more advanced, more complicated tools to install and build bigger systems to do better things. For the next, be it 2, 3, or 4 years you're here, why is Linux important? It's going to be required for some of your classes. So development for some of these classes is only going to be officially supported in Linux or potentially Unix-based system like macOS. So ECS 338, which is the operating systems course, and 293, which is the very, very highly recommended technical elective. You're going to need to use Linux or Unix to do your work. The computer engineering courses, ECS 315, Digital Logic Design, and 318, VSLI, require you to use very expensive tools that are only available on school Linux computers, so you're going to need to use remote access or go visit those computers to actually complete your work. So you need to know how to use Linux. It's also good for your life. You'll be able to use it to do whatever daily programming you do. You can use it to build any tool to help you, and generally, they'll make you have a good time. So if you want to try Linux, if you're already familiar with network access, you can SSH into the Jennings lab, or you can visit the Jennings lab. But where is the Jennings lab? So the Jennings lab is on the 4th floor of the Olin building, which on the engineering quad, there's 3 buildings, Glennon, White, and then Olin, moving from Veal towards Nord. So Olin is the very tall building on this end of campus. So on the 4th floor, there are 2 computer labs. One is the gaming lab and one is the Jennings lab. So the Jennings lab has a collection of Ubuntu computers that you can log into using your Case ID. And it also has some workspace if you just want to set up your laptop and work there. If you want to try Linux without actually changing your computer, you can start using a virtual machine, using some program like VirtualBox or Parallels, and install it. And if you have a powerful enough computer, you can even do all of your work right there. Or if you're feeling more trusting about your ability to keep your computer working, you can do a multiple OS install or just convert your computer to using Linux. Or if you don't want to mess with your primary machine, you can install Linux on a different computer. And so there's plenty of tutorials and resources online. If you want to come into Glennon, you can probably track down one of us who can give you some assistance with working with Linux. So you might ask, why move on from the mouse? So the underpinnings of Linux and all of these systems is using the command line. So your IDEs and other GUI applications run as a mixture of interface code, or they access the installed system tools you already have. Or, in some cases, they just re-implement the tool so that they can do it their own way, which is not very beneficial because it sort of gives you a completely separate implementation that may be just so slightly different from what the standard is, that if you break from using that tool, you can't use the conventional tools that you can get anywhere. So running the tools yourself gives you more control over the execution of the tools and can allow you to combine those tools in ways that you wouldn't have necessarily been able to given the constraints imposed by the designers of a GUI or IDE system. So with that, I'm going to move over and hand it off to Andrew Mason for a live demonstration and some comics.
This is just like well, so I was not expecting to have this much time to talk, so that is actually really good. Sorry. Can we move the screen up so I can have the bottom half of the board? Thanks. So I'll just kind of leave this here while I talk. So a couple of things that Thomas talked about that I want to touch on. There's a lot of resources out there. We will send out resources probably by tonight, maybe by tomorrow, for more information about how to get Linux set up for you, whether that's on your machine or as a virtual machine or whatever is best for you. If you run into trouble with that or you're not super confident, that's totally fine. Tim mentioned we have open hacks from 2 to 4. Actually, he didn't say it was from 2 to 4, but it is from 2 to 4 on Sunday in the Glennon Sandbox. That's like the big glass room that they probably took you by on the tours. I will be there the whole time. I will be teaching an introductory Python session from 2:30 to 3:30. But outside of that, I will be more than happy to help walk you through a Linux install or answer any questions you have or go over anything that I talk about right now if you are confused or want to know more. So I'm just going to pull up a VM just to show you what that looks like. But I'm going to do all of my demo on my actual machine. But if you were using a VM, you would run it in something like VirtualBox. And then you would have installed it already, but that takes kind of like 30 minutes, which is all I have. So we're going to start with it already installed. And it's going to boot up. And I'm running Ubuntu, which is a pretty, I think it's the most popular Linux distribution. Oh, that's, that's probably fine. Okay, so this is what a Linux desktop looks like. Or this is what the Ubuntu desktop looks like. It looks pretty similar. You know, instead of the navigation bar down, or like the toolbar down here, it's over here. Instead of a Windows button, whatever that does nowadays, you have the Ubuntu logo, which is that circly, swirly thingy. And then we have the terminal, which I'm going to talk about on my own machine. Because I have files that I've cherry-picked for this demonstration. So we're going to pull up terminal and full screen that. Can everyone see that color? Is that fine? Font size is also fine. Good. Smaller font size, bigger? All right. Give the people what they want. Good? All right. So this is a terminal. Yours won't look exactly like this because I've done things to make mine look in a particular way. That's fine. Basically, you get a prompt, and that's what this cursor right here is. And I type things, and then I hit enter, and it tries to run what I typed. That is obviously junk, so it can't run that. That's totally fine. Very basic thing is echo. Echo does exactly what its name implies. It spits back out what you give it. So if I say echo hello world, I get hello world spit back out. Next, I'm going to move through the first couple kind of quick because they're basic. And then once we get to the other ones, I'll slow down and go over a little bit more. Next one is super important. This is man. Man is not gender. A lot of Linux commands are abbreviated of what the full thing is. So man is short for manual or man pages. I don't know. There are man pages for every tool in the Linux system. And so so as Tim was mentioning, the way that you learn something is you read the documentation. So with man, you type man and then the name of the command that you are interested in learning more about, and you get the documentation for it.
So I will pull up man echo. And so now I get all of the documentation about echo. So now I see echo takes an optional argument -n, and it says do not print the trailing new line character. So when I ran echo before, it typed out hello world, and then it put my prompt on the next line. That's because it printed out a new line. So now that I've read the documentation, I know that I can say echo -n, hello world, and now it doesn't print out the new line, and my terminal is all mushed together and ugly. And this is why echo prints out the new line by default. So as I said, you can get the man pages for any, if there are questions or if I'm going too fast or you don't understand something, I will try to look up, but if I'm not looking up, just yell at me and I'll answer it. So man gives you the man pages for any command. Man is also a command. So you can get the man pages for man by running man. And there's a whole bunch of options. I have no idea what they do. I would if I read this, but that is not what we're talking about right now. The terminal is used a lot for file system manipulation. So in Windows, you open up the Windows Explorer thing and you click around and there are folders and files and you can drag them around and make new ones and put them in new places. We can do this all without our fingers leaving the keyboard. So the first thing is it's important to know what directory you are in. And the way that you do that is you print your working directory, pwd. And this will spit out exactly where you are. So I'm in /user/Andrew. This tilde thing is an abbreviation for my home directory for whatever user is signed in. So I'll get to that in a second. Next thing that you want to be able to do is I know that I'm in my home directory because I printed out and I'm in /user/Andrew, but I have no idea what's in here. I can't see it. So the way that you see something is you type ls. Probably stands for something. You can think of it as list stuff. And so I see this is colored, so the blue things are subdirectories. So I have these standard ones that come on Macs. This is where my VMs sit, and then 3 that I actually use. And there are a couple options, like you can, what? Blue, LS what?
-- color equals never. Change your GNOME terminal or you can just change the terminal colors. Well,
yeah, but who knows what ugly amalgamation that could result in. I have a great idea. Let's read the man pages.
This highlights the big difference between Macs and Linux though. That command probably works on Linux, but not on Mac. Because all the commands are like just subtle.
There are subtle differences.
Yes.
Generally, you're fine.
Generally you're fine, but there are subtle differences.
It's yelling at you for the color. Maybe it's just -C. I don't know.
it's -G, I think.
-G? All right. You've tried, you failed. We're going the other way. White can't possibly be that painful, right? How do I make it do that? Maybe I just hit default and then it's like magic. All right. Hopefully we can deal with the very white. What was I talking about? Oh, you can also pass. If you don't want, so the man pages, right, are kind of long and they're a little intimidating looking. If you ever want to know how to use a tool like quickly, most Unix tools will take a -help or a -h flag, except this one. I know other commands that take -help, but in any case, you can also see that ls takes a file argument. So by default, ls will print out your current working directory, but you can also say, show me everything in Hacsoc. And then I get a list of all the things in Hacsoc, and I'm going to get rid of some of those. So I now know what's in the Hacsoc directory, but I'm still in my home directory, so I need to get there. And the way that I do things is I change directories. So cd is change directory, for obvious reasons. So I'll cd into Hacsoc. Now, my prompt does it for me, but if I were to print my working directory, I'm now in /user/Andrew/Hacsoc. And now if I ls, we see that we got the same thing as when I did ls Hacsoc from my root directory, or from my home directory. There are 3 magical file paths that you can give to cd that will do particular things. One of them is the tilde. The tilde is a representation of your home directory. So when I do cd tilde, it will take me back to my home directory. There are 2 other ones, and they are dot and they are double dot. Dot references the current directory that you are in. So if I say cd dot, it looks up what my current directory is and sees that it's tilde and does a cd into tilde. But because I'm in tilde already, this does absolutely nothing. But it's used in other places. The other one is double dot, which says go up 1 level. So this takes me up to users. And when I was in tilde, I was in /user/Andrew. So it makes sense that when I go up 1 level, I'm in just /users. And if I go up 1 more, I'm in just /. And if I go up 1 more than that, it does nothing because / is the root of the entire file system, so you cannot possibly go higher than that. It's also worth mentioning that all Unix systems support tab completion. So if you do it with nothing, that is not helpful. You want to start typing what you want and then let the shell help you get the rest of it. So I can see, let's say I wanted to go into the Jolly Advisor, but I didn't remember if it was underscores or dashes between the words. Well, I know that it's in Hacsoc, so I can say cd Hacsoc and then type the, and then hit with a single tab, it completes. So you'll also see I have talks and the Jolly Advisor. An interesting question is what happens if I don't give it enough. So T, it clearly won't be able to tell the difference of whether I meant talks or the Jolly Advisor. So if I tab, I get nothing. If I tab again, it shows me, hey, there are 2 options. Mine is not set up, but on some systems, if you tab a 3rd time, it'll actually highlight which one it's on, and you can hit enter and it'll grab that one. That's cool. But I want to go into the Jolly Advisor. Okay. Ignore this and that. It's not pertinent. Next, so we know how to move around. We know how to see where we are. That's great, but this is all with files that already exist. We haven't been able to add any new files. We haven't been able to copy files, rename files, or anything. So that would be great. If we reference the comic, what was that Linux command for creating a file again? If you remember, your Daft Punk is touch. So first I'll ls, so you can see there's a whole bunch of files in here. Let me actually, I'm going to quickly make a directory. I'll go over that in a second. But this is clearly empty. If I touch food.txt, now there is a file. It is empty. That's all touch does, is it creates a file. The file already exists. It just updates the timestamp on when it was last saved. But I decided foo is a bad name. I don't want this file at all. So I'm going to remove it with rm. So I'll tab complete the foo.txt, and it's gone. Questions? So that's how you make files. But it's also really helpful to make directories, because directories are what Linux calls folders. So Windows folder or Linux directory. Directories are great for grouping related files together, say for your homework. This is my ESIS 132 homework 1 directory, and this is my homework 2 directory. That is a good thing to do. So in order to make a directory, you type make dir. I call it make dir. Some people say make dir. Whatever makes you happy. So you make dir, and then you type the name of the directory that you want. And just like how you can remove a file with rm, you can remove a directory with remove directory. And this gets rid of temp. One thing that you'll probably run into across in your, that's a very loud bell. I didn't want TM, but that's okay. This will actually serve my purpose even more. So I will put a file in the TM directory. So now if I ls TM, you see that there's foo.txt again. And I want to get rid of the whole TM directory. And if I try to remove the directory, Unix yells at me. I can't remove empty directories because that's bad. There might be a file in there that you didn't realize was in there, and you shouldn't do that. But Unix is very, very configurable. If you really, really want to do something, you can say, hey, I really meant this, please do it. And the option here is you want recursive. So this will go in, this will remove files and go inside of directories and remove all the files and keep going down until it runs out of files. And so if I remove recursively TM, then it happily complies and it's gone. Next, so we can create files, we can remove them, we can create directories, we can remove them, we can even remove non-empty directories, which is great. So let's say I have a file and a directory, and I want foo inside of foo directory. These files are empty, so this is kind of a trivial example. I could just remove the foo file and, or not even remove, I could just cd into foo directory and touch a new foo file. But let's pretend that foo has some contents in it, and I don't want to lose that. And I also don't want to sit and manually type character by character all of the contents of foo because it's 200,000 lines long. You can copy a file with the copy command. So you can copy foo, and I want it inside of foo directory, and foo is still here, foo directory is still here, and if I ls that, now there's a foo inside of there. Now I'm going to touch bar, so now there's a bar file. Foo left a copy because that's what copy says, it copies the file. I now don't want to copy it, I want to take the actual bar file and I want to remove it from the directory it's in and put it somewhere else without destroying the contents, same thing, so I can't just remove it and create a new one and copy all the contents over. The way that you do this is with move. So I move bar into there. And now bar is gone, and if I look inside of there, I see foo and bar. So this is the difference between bar and, or move and copy. Questions? Is that my phone? Guys, stop. Yes. Oh, yeah. Very sorry. That looks so much better. Okay. Yes, question.
What's better about this than clicking and drag?
I can touch a lot of files at once. What is the next one in that sequence? I don't even know. But let's say I went to touch bar and I accidentally hit the T. So I typoed. I need to rename this file, otherwise I'm going to get confused because I meant it for it to be named bar and it's bad. Well, move takes a file from where it is and puts it somewhere else. And I get to specify the new name for the file. So move is also used to rename files. So I can move bat to bar. And so remember before we have, actually, I'll show you. So we have bat and no bar, and I will move bat to bar, and now we have bar and no bat. So all these files have been empty, but I told you to pretend that they had lots and lots of content in them. Otherwise, everything that I did was kind of silly. So now we'd like to be able to see what's inside of the file. So we can do that with cat. Cat will print out the contents of the file. So bar is empty, so we get nothing. We're gonna print out a project that Steven did. There we go. So this project was done for the Python and Pi that we had on Saturday. This is a Twitter bot that if you tweet at it, it will look inside of this taylor.txt file and grab a random Taylor Swift lyric and tweet it back to you. So let's look at all of Taylor's lyrics. There's a lot of them. So remember when I said about large files? You don't want to remove this file, touch it someplace else, and manually go back and enter all this in. This is why move and copy are very, very helpful. So cat gives you the contents of the file, but this is kind of bad because this, I don't know how long this, do you know how long the file is in lines?
12,000 lines.
This is 12,000 lines long. I'm not going to scroll back 12,000 lines to read the first line of this file. That's ridiculous. And somebody else thought that this was ridiculous too when they had cat. Yes?
How do you find out how long files are?
We're getting there.
Okay.
Relax, man. So somebody else said, this is really terrible. I have these long files and I can't read the front of them. So somebody wrote a tool called More. More takes a file and it basically scrolls it for you. So when I more, I get the top of the file and then I can scroll down. This is sort of what the man pages look like. Man pages are not actually moored. Somebody else was not happy with more because more you couldn't scroll backwards. And being as clever as they wrote another tool and they called it less. And actually on Macs, the people that wrote this shell decided that more was not as good as less. So more and less actually point to the same executable and they do the same thing. And so less is more on your Macs. So now I can scroll forwards and backwards and everything as well. And that's actually why I didn't even try to scroll backwards earlier because I knew it would work even though I told you it wouldn't work. And just to prove it to you, when I man a command, it tells me the name. If I man more on a Mac, it says less. This is on Ubuntu, that's not true. On Mac it is. So that's really good, and all is well and fine, except I have to scroll every time. And maybe I just want the first 5 lines and that's it. The beginning of something is generally, like if you think about animals, the head is the beginning, and then there's the body, and then there's the tail. So if I get the head of the file, I think I can tell it how many lines I want. So give me the first 5 lines. And that's it. And similarly, I can say tail. This will give me, and just to prove it to you, not head. You were what I wanted. If anybody knows these songs, you can maybe remember it even better than I can. Those look the same to me. Great. I can also tail a file. Let me cat it first. So this is the bottom. So we're going to get the bottom 2, and it should say, lost your balance on a tightrope. It's never too late to get it back. And if I tail to Taylor, I get those 2 lines. Question?
Yeah, so the only difference between less and more is that less lets you scroll backwards and more does not?
Less has a bunch of other stuff built in. I was reading yesterday, basically Less got open sourced and then people started saying Less would be really great if it had feature X. Less would be really great if it had feature Y. And so they kept dumping things into Less. And less's source code is like 10 times longer in magnitude than Moore's.
So less is actually more.
Yes, and there's actually a third tool called most, which I don't have, but you can read the documentation on your own. It is not very hard to read. So cat, more, less, head, tail. Great. No. So Jeff very nicely asked, how do you know how many lines are in a file? There's a tool called WC. So WC is for word count, but it also does line counts, character counts, and byte counts. So with the -L option, I can count the number of lines in each input file. So I can say WC-L Taylor.txt, and now we're going to test how good Stephen's memory is. 12,141 lines. It's not bad. Okay, so those are all of the tools that I wanted to go over. Does anybody have any questions? Yes?
So I'm just curious, you demonstrated this on Apple OS and on Linux. What's the difference between those and, say, a Windows operating system?
You don't have all of these tools. You have some of these tools. You also have some of these tools, but they have different names. You have some of these tools and they have different names and they take different options. So the -- color, oh no, it's equals off, oh no, it's -G, oh no, it's big G. You're gonna run into that, but even worse. So like instead of LS, it's dear. I don't even know what the equivalent of touch is. I don't use Windows a lot, so I just know it's a different environment. Any other questions before I start using the board? Cool. So now we need to edit files, but we're going to edit files without using a text editor. We're going to use the shell as our text editor. So this is a process. Every command that we run is a process. When we type a command, a process starts and it does the contents of the command, and then it terminates, and then the process dies and goes away. A process gets input via a thing called standard in, or stdin. And then a process spits out output. But when Unix was designed, it was decided it was better that there should be two outputs. One of these is standard output, or stdout. Most people call it standard in and standard out. And then the third one is standard error. So the idea is if you operate normally, you print things out on standard output. If there's an error, you print it out to standard error instead, so that the messages go two different places because they mean two different things. You can do things with standard output. You can take the standard out of one process and you can redirect it someplace else. So echo takes a string, it takes some characters, and then puts it on standard out. Standard out is what we see, so like this gets put on a standard out. Actually, if we even looked at the man pages, we see it very explicitly says is written to the standard output. So we know that the things that come up here are standard out. So that means we can assume that when I say echo hello, hello gets put on standard out. So I can take hello, oh, there's no kick, and then with a angle bracket, I can say redirect standard output and put it into foo.txt. And so this will take the string hello and it will take echo's standard out and shove it into this file. And so nothing gets put on the console because standard out has moved someplace else and it went into foo.txt instead. So if I cat foo, hello is inside of there. Questions? Yes?
Does it override what's in foo? Or is it just part of the yes?
There's a really great way to find out. It overwrites it. This is why you don't use echo and standard output redirection as an actual text editor. You will be not very happy. Yes. Wait, this? Yeah, this will append.
Yeah.
I thought you meant this. That does something else. Okay, yeah, so I can say put hello into foo and then does not append new lines though. Oh, that's very bad. Don't do that. Oh, it does do it. Oh, because echo has a new line. If I then did echo dash n, yeah, dash n exclamation point into foo. Oh, it's trying to evaluate that. Single quotes, my bad. Then I can cat it and great. It's very pretty.
I have a question.
Yes.
When you type cat and hit return, so type cat.
Yeah.
How did you escape this
Oh.
bad state that you were in?
That
everybody?
is a great question. So first of all, what happened when I hit this is when cat is not given a file as input, it looks at standard in. So cat is waiting for me to type things before it can do stuff. What I did to kill it, which as you can see, so this will never terminate. We can sit here all night and it'll keep going. Actually, my laptop will run out of battery. That is when it will die. This thing is a textual representation of Control-C. What Control-C does is it sends a signal to the process, which is called sigint, or signal interrupt. So it tells this process, I am interrupting you, stop what you're doing, you're going to be shut down. And so cat says, okay, and then it shuts itself down. So I Control-C, and then it stops. I was going to talk about some. Oh, the to thing. So when I thought he meant this, there's two outputs, right? This one is standard out. This one is standard error because it's the second output. So I can generate an error by doing this double quote exclamation point thing again. And I can echo that into foo.txt, I think. Nope. Huh?
It's a bash error, so it won't be a.
Oh, it's not. Yeah, it has to be a. Do you know how to make echo trigger an error?
Just use cat as a file that.
Yeah.
Use the actual echo on the file system.
What?
Use the actual echo on the file system you're using the bash built in.
This one?
Yeah.
Nope. All right. So. All right, we'll try it. There's another way that you can shove processes together. So we figured out how to shove processes into files, or the output of processes into files, but you can also shove processes together. Because you can say, sorry, Tim. You can take the standard out of one process and you can feed it as standard in to the next process. And you do this via a pipe character, which is a vertical bar. So I can cat foo and pipe it into echo. And is foo empty? No.
Takes command line arguments, not standard in.
I would have to do evaluation for that. Give me something else that I can pipe quickly. Yes, and this will trigger an error. This is great. All right. So I can take the output of foo and I can pipe that into cat. And so now cat will take the contents of foo, which is hello, new line, world, new line, exclamation point, and it will try to cat that file, which obviously does not exist.
It's going to take stuff from standard in.
Wait.
It's actually going to work.
Oh. You can tell I don't play around with these tools very much. You can do.
That's a good example.
Okay, that is a good example. And I do that all the time. I don't know why I didn't think of that. So, See, because I didn't talk about grep. That's why I didn't think of that. Grep is a tool. I'm really falling apart here. Grep has crazy documentation. All it does is it looks for patterns and returns results that it matches them on. So I can cat foo and pipe that into grep, and I want to find the lines where there's the word hello. And now I just get hello. I haven't changed cat, or I haven't changed foo. It still has all the files. I can also grep for world. This is empty because it doesn't match lowercase because the W is capital. Is it -I? Yeah. That is for insensitive, like case insensitive. So this will just ignore case. And we'll show you the line. What? N? Yeah. Another great thing about dash is I don't know if it's possible to learn it all, but everybody knows a different part of it. And so you can learn things just by talking to other people, like Tim is teaching me right now. Huh? What? That is true. You can go talk to him. So now we see that it was on line 1, and if that was almost really bad. If I grep for hello, it's on line 1. Questions? Yes?
So can you write like a script to do all this for you?
You can. Let's very quickly. Okay, I'm going to use an editor that I really like. We're not going to talk about text editors. You're just going to let me really quickly write this file, and we're just going to pretend like it was there the whole time.
3 weeks. You're going to talk on this text editor.
On this very text editor. I love this text editor. People in the audience will complain, and you can start a whole holy war. So we're going to call this cat grep. So .shell says run this as a shell. I'm not going to talk about this weird thing that you see. It's just going to magically work. It's all going to be fine. So I can say cat foo.txt, pipe it into grep, show me the line number, and look for a hello. Okay? Cat grep. All right. So I will, I need to go back to where that file is. Yep, Hacsoc, pi. Okay. Now I need to say bash because I didn't make it executable. And run this here. Make sense? Any last questions? All right, cool. I will be in Glennon Sunday afternoon, mostly teaching Python, but I will answer questions about Linux or, yeah, hold on. We still want to talk at you. If you have questions about Bash or anything else, I will be happy to answer them. Tim wants to talk.
Yes. If you want to learn more, and Andrew is talking to somebody else already, because there's like 200 of you, there are lots of good books on it. I can recommend Unix, A Quick Start Guide. There's another one called Linux, A Quick Start Guide. It's on Safari Books on Tech, which you have free access to via the library. Go to KSL's page, which is like library.ks.edu. So go to like ebook collection or something on there, and you can find Safari Books on Tech. If you can't figure out how to do that, ask me, ask a librarian. There's a lot of great resources. They're all free to you while you're here.
We have one more quick announcement.
And we have another quick announcement.
One quick announcement, and then we'll let you go.
So, as we were saying before, there's
You've got no input.
I don't know why.
All right.
Oh yeah. So while he's setting up, real quick announcement. Remember Open Hacks, Sunday 2 to 4. We also have our Lake State Conference, which is October 3rd. Tickets are live. They're on our website at acm.case.edu. It'll take you to the Eventbrite. If you don't know what Lake State is, the TLDR, it's a day-long conference of really cool talks from professionals in the industry and some really great students here. Come on down. It's at Case Western. You'll have fun.
And
So anyways, I broke the projector system, but I run ACM's IRC server. So if you've never heard of IRC, it's this wonderful thing that was invented in the 80s. It's old, but it still works. So if you go to irc.case.edu, it will tell you how to get connected, and you can chat with pretty much all of us anytime you want, because we have nothing better to do. If you have a question on anything you learned here, you can type in Mason : and he will answer.
That's true.
IRC is really great for when you're in big classes like this and you're getting bored. But no, you'd never get bored, right? But like if you want to talk to each other in class, that's like the thing to do. Hop on the IRC and you get like your own code name. It'll be like you're 12 again in chat rooms. It's really fun.
It's like AAM for grown-ups.
It's AOL online, but way better.
Yeah.
okay, and one final thing. Next time, watch your email to find out whether we're here or someplace else. We're gonna have Andrew. You're gonna talk about Git.
Yep, and I actually know what I'm talking about there, so.
Yes.
Yeah,
So
Linux
Andrew's
is
gonna
so
talk
you know how
about
to
Git,
use
which
them.
is about like putting a safety belt on while you're using the command line, because it's really easy to like delete all of your homework from the last 5 years. Like that rm-r, you could delete everything you have and be very sad. So like he's gonna teach you how to put that safety belt on. And then I'm gonna teach you about something called Gradle, which is a build system for Java. Many of you are going to be using Java in classes this year. Gradle can make your life a lot better and make you cry less as well.
We have some chips and cookies if you want to grab some. There's also exactly 5 sandwiches. May the best hacker win.
All right. Excellent. You're very well. Thanks.
Yeah, I was getting confused about saying your name. What things? Because what I really want to do is I just wanted to do a shell evaluation there.
I gotta go rest my backpack before.